In sagemath topic, our next section is graph limits and continuity of functions. So in this tutorial we will mainly focus on graphs. Plotting of graphs is the important point that we are going to discuss. How can we plot different types of graphs? What are the commands that can be used to plot graphs? Also, how can we make changes in the plot of the graph? And these are the main points that we are going to discuss. Okay, plotting of graphs. Here we have basic plot of a graph. So we will discuss how to plot graphs using Sage and how to utilize various plot options. We will discuss in detail several options that will be useful in our study of calculus. So that will be at the end of this, if possible, will be included at the end of this video. Otherwise, a separate video will be done for explaining the applications of sagemaths or the uses of sagemaths to do problems in calculus or to find the limits and continuity. So that comes as the second and third section of this unit. Okay, here you can see the syntax of the plot command. Plot fx. Here fx stands for the function that you wish to plot, and the variable present in the function is x, and a and b stands for the range in which you want to plot the function. Okay, for syntax for plotting the graph for a function y equal to fx with x ranging, here x stands for x ranging in the interval a b, x ranging from a to b is given here. Okay, let's consider an example. Developing an idea through an example. Entirely the things are developed here through examples and giving demonstrations of those examples. So this is the best way of learning and teaching and learning. So I think you can grasp the idea very you can grasp the ideas very easily and quickly. Here consider the function fx equal to 2x square minus 4x plus 2 along the interval. On the interval minus 3, 5 is the interval given. For that, for plotting that, in the command used is here you can see g equal to extra and extra g equal to is used. The word g and equal to is used in addition to that plot command and its syntax. Okay, and it's because by writing this as g equal to plot, etc., here we are defining a variable, and then we are assigning that plot, the output of the plot, to g, and then after implementing this step, if you want to display the plot, then you can just type g, and by entering by the command or by using the method to obtain the output, you can see the output just by typing g, and you can easily take the output out after that. So let's try this in the Jupyter notebook. Okay, here is I type this. I type that material, and then you just end, and you can see, and there is no error. So if you type if you press alt enter, if you apply Alt Enter, then you can see that the input new input cell is has opened, so it says that there is no error in that command. So to obtain the output, what should you do? You should type G, and you can take the output. See, that output has come here. It is appearing here. Yeah, this is the graph of that that function 2x square. 2x square, graph of the function 2x square, ranging from -3 to 5. You can see -3 here. That range of that the graph is here plotted from ranging from -3 to 5. So on that interval, it is it's plotted. It's how easy it is. You can see. So for understanding graphs and graphs, the nature of graphs, and to study more about the functions and their graphs, this method can be used. So in calculus, it is very important, and has very much applications in calculus. Using this method, using sagemath, you can make calculus very interesting, and also very easily you can make that you can make your learning very easy and very simple, very easy and simple. It can be made very easy and a simple task. Yeah. Okay, let's try with some other some different one. Yeah, here we have the function y equal to sine 2x to plot y equal to sine 2x on the interval -3, 3. We use in that command. You can use a similar one. G equal to plot, then in bracket sine, then angle must be given 2 star x. 2x is written 2 star x, then comma x comma -3, 3. Interval is given. X is the variable used. X is the independent variable used, and the interval is -3 to 3. You must get an output like this, which is displayed here. So let's try with this. And the next line itself, you can take that output just by typing G and press enter. Yeah, you can see this is the graph. Let's compare the graph with the manual. Yeah, study material. Yeah, it is same. It's -3 to +3. That graph you can see displayed here. Okay. Next here, the question is plot the graph of the two functions. You can expect this kind of questions in the examination also. So plot the graph. Plot the graphs of the two functions given in example 1.1 and example 1.2. In example 1.1 and 1.2 prior on the same set of axes to show their points of intersection. Here the aim of this problem is to find the point of intersection of two graphs or two curves. Suppose we are given two curves, and we want to get an idea about the point of intersection of the two curves, if there is any point of intersection. So if they do not intersect at all, then there will be no point of contact, no common point shared by the two curves. So that way you can say that there is no intersection, there is no point of intersection. But this is possible only in a given interval, in a given range of that curve, in a particular interval where that graph is drawn, actually drawn, not on the whole interval. It's possible to apply it on the whole interval, from minus infinity to plus infinity also, but for that you have to give that you have to change the limits, lower limit and upper limit in the function. Okay, the functions are, the two functions are, first function is the first function is 2 into x square, 2 into x square minus 4 into x square, sorry, 4x plus 2 is the function. 2 into x square, 2x square minus 4x plus 2 is the first function. The second function is sine of 2x, and these are the two functions here, the same functions. Okay, here the functions given in the previous two in the two previous cases are the functions used here. The first one 2.1 and 2.11 and 2.12 we have used these functions, and we are going to combine these two functions whether and we will look at the intersections. Okay, for that see how did they write that command. You can see g equal to plot, then in bracket the first function and second function are given separately, separated by commas. They are given separated by commas, and then x variable and then in the interval, and these are given. So the main difference is that there is no single function, and the two both functions are given separated by commas, and properly the the brackets are here, the brackets are properly included, and that's very important. Missing of bracket will lead to syntax error, so very important. It's a very important point. Okay, let's copy that and we apply it, we input it in a window, and then type G and then enter. Okay, let's take that output. Okay, you can see that in two different colors it has it's drawn here in two different colors. One, that curve is used, sorry, that parabola shaped curve in blue, and that sine curve in appearing in green, and also you can see that there exists 2 point of intersection. This kind of graphic, this is the graphical way of graphical method of finding the point of intersection here. But one problem is that, one drawback is that for this method that you cannot exactly say that say the value or the value of x at which the curves meet with each other. You cannot say what is the value exactly you cannot, but you can approximately say at which point the two curves intersects at the first place, and at the second place at which point, or the value of x for which the two curves intersect the second time. Okay, for exactly obtaining the values, there exist methods, and that methods we will discuss that later, and that methods can be used. Such methods can be used, but this is only an approximate method to say whether there is an intersection of two curves in a given interval. Okay, next is we have a little different and little more complex functions. Two complex, not complex functions, complex expressions are there. Yeah, it's a fraction. One first function is it has numerator denominator part, and both has numerator and denominator part. The first function is 2x square plus x plus 2 divided by x plus 1, and the second x function is cos 2x divided by 2. Here we are going to what's the question, and plot the two curves, or plot the two graphs given here as f and fx and gx on the same set of axes, and show the output, and that is the question. That's the question. Okay, here this is the, let's analyze that. Again, g equal to plot, then in first bracket is open, this bracket open, here will close finally there, and then inside that another bracket is opened, it will be closed here. Here it is closed, and inside okay, yeah. Then inside again one bracket that stands for the first function, that is used in the first function. First function starts here and ends here, and then comma, and the second function starts and ends here. So this way very care must be given while typing, while entering the functions in the command. And then x variable, and then we choose the interval from -5 to +5 on which the curve is to be drawn. Okay. Oh, what is that? Something more is copied. Something. Okay. Just up to that point, up to that end of that function must be copied, and then you type G, enter. Yeah, we have got that. Figure. Here you can see that this blue comes here, and it does not go to that go beyond this limit. You have that x-axis. This is the x-axis, and this blue curve, when as it approaches that x-axis, you can see that it takes a turn to the left side. It deviates to the left side, and it does not go straight beyond that x-axis, and it doesn't touches with the other part of that part of the same curve. But the same thing you can see at the upper part of that figure, and there also here that curve comes down, and it turns to right, and it goes. It doesn't cross that x-axis. Okay, but the line, the other one, sine curve. Okay, but what has happened to that? Sorry. Yeah, it's the function cos. The second function is cos. Cos 2 into x divided by 2, and that curve, that curve is drawn here in green color. So in blue color and green color you can see the two curves. These are the two curves, and the output obtained here. Output of the two curves obtained here. Okay. Here, note that some few words about that function. Note that the graph of gx cos 2x by 2 is displayed poorly in output because output above, because its range, it ranges from -1 to +1. Range from -1 to +1 is too small compared to that of the range of fx equal to 2x square plus x plus 2 divided by x plus 1. We can zoom in by specifying the value of vertical line using y minimum and y maximum. We can zoom this figure. It's how this is the zoom is applied here. You can see that y minimum and y maximum, and by specifying that y minimum and y maximum here, you can zoom that. Okay, so additionally we are going to include this two more values, y minimum and y maximum. Y minimum equal to -10, y maximum equal to 6 in the command. So for that, let's come back, and we will copy again. We do not want to change it, change the existing step. So copy, we take a copy of that and paste it, in that we will make the changes. The changes are additionally we want to include y minimum equal to -10. Okay, that after 5 you can include it separated by comma. After 5 it is taken y minimum, that is the minimum value of y, it is -10, and the my y maximum value of y, it is it is 6, must be separated by comma. Okay, included. After that you can take the output. Okay, okay, that does we get that figure, we get the output here. Okay, and this is the output that we got. Okay, exactly same as the one given in the material. Okay, and when we compare that, okay, this has given us the effect of zoom effect. Here, what is zoomed? We have zoomed to this point. You can see here. Here, this is the actual happening at this point. You can see that here the curve, the blue line here is separated. This actually this is a part of this curve, and both are same. Both belong to the same curve, and these two parabola like curves belong to the same curve, and here it does not join. But they are separated, and as it reaches here, it then goes in that direction, and here it comes in this way and goes in this direction. Okay. That you can see in at a distant view. You have here a distant view, but with a close view you get a close view at that point, or in the neighborhood of this point where that curve breaks. And here you can see that the second function, that is the cosine function, it has a wave-like curve, and that goes in between these two separated curves. Actually it does not intersect, but if in this distant view you cannot get an idea about that the nature of the curves actually. So this kind of zooming helps us to know more about the nature of the curve. Okay. Next plot the graph. Okay, this is given as a question here. Plot the graphs of the following functions: fx equal to 2x square divided by 2 minus x square, and fx equal to 2 sin x plus cos x, fx equal to x e raised to x plus integral of natural logarithm ln of x, natural logarithm of x, and fx is equal to x square divided by x square plus 2. Solutions are also given. Okay, you can take this as a question, and we am not going to demonstrate these three functions because it is very easy, and so it is left to you, the students. It's a work given, it's a homework given for you to do. Okay, next the plot important. We are coming to the important plot options. Very important plot options are given, and along with its syntax, and that is the title. You can include titles that you like, that you wish, that title you can include in the graph of. In the picture of the graph, you can include a title. So for that you can use the command that after that plot after the plot command, you can after specifying the intervals a and b, then comma, you can put a comma and then title equal to, in a double quotation mark, the mark you can enter the you can include, or you can enter the title of the graph that you wish to display. Okay, and then another change is that another command is figure size. The size of the figure can be varied, can be changed according to your wishes, your interest, and your convenience. You can change the size of the figure, but for that you have to use this word size, figure size. You have to use How can we use that inside inside the command? Plot then fx then x a comma b, and then after giving a comma, figure size equal to a number. In here you must choose a number. So what you can do while trying with the sagemath is after implementing or after using that command, you can you can make one by one these changes in a previous command, and you can obtain you can take the output and you can compare the output obtained in each step. In each modified step, you get an output, and those outputs can be compared with the basic output that you have obtained when you have entered the basic command. By basic command, we mean a command like this. In this command, if you enter this command, you will get this figure as output. After that, you can make the changes in that base expression and obtain different outputs, and you can compare it to see the changes. So here next is to change the color. You can draw the graph in different colors. To draw the graph with a different color, how can we do that? Plot then function fx, plot fx, then xab, and then color equal to, you can write color equal to a color name can be specified. Now draw a graph and specify its thickness. You can vary the thickness of the graph. You can vary by using this command, plot fx then x comma a b, and then color. This is color specifying step, and then thickness can be specified putting comma, thickness equal to a number. So that number indicates the thickness. As the number value changes, you get curves of varied thicknesses. Curves having different thickness can be obtained by using variations in the number used here. Draw a graph with to draw a graph with line style, with specified line style and legend label. Line style and legend label. The command can be written as given here. Plot fx, x, a, b, color, and color can be specified. Then line style. Line style is the new word that is included here. Line style equal to line style, that dot then gives us the dotted line, and thickness gives us the thickness curve in different thickness, and legend label equal to fx. So legend label can also be given. So here you can see that this command is a lengthy command, because many functions are included here. Many activities can be done using this lengthy command. Now we have the command frame option to, you can use frame option to put a box around the graph. That graph can be enclosed in a it can be enclosed in a box using the command frame. So for that, syntax is plot fx, x, a, b, and frame equal to true. Frame equal to true value must be given for that. And then axis label can be given using the command plot fx, x, a, b, and then axis underscore label. Axis underscore label equal to in square bracket x-axis, and label can be given, and y-axis label can be given. Along the x-axis units are taken, so unit label can be given this way, and along the y-axis we take a unit. Okay, units actually means different units that you can give. Unit name can be mentioned there, that will be displayed in the graph. Okay, then to draw an ellipse, you can use elliptic plot. For drawing ellipses, you can use elliptic plot. So elliptic plot, in elliptic plot has the elliptic plot has this syntax, elliptic underscore plot, and fx, xab, and ycd, xab, ycd. Okay, with applications of these commands we will come back. So we now at this moment we want to stop this video. Okay, thank you for listening.